Normally I type this up because my handwriting is atrocious. If you can't read my writing, ask. I will not make fun of anyone ever if they ask me to translate my writing. It's bad. That's the one time I won't make fun of. Yes? Nope. But I think you'll figure out most of this. Okay? So the first thing, on your test, on the, I think it's the last page, I'm going to give you 3, maybe 4 equations to, I'm going to say more than balance, predict. And the first type is what we call, and come back here. Turn the pen off, Mr. Dueck. Do this, do that. There we go. Acid, base, base, neutralization reaction, which sounds really, really fancy, but when I show you an example, you'll go, oh, that's it, that's it. So hopefully you have a piece of paper somewhere. And I'm going to say something like this: balance and predict the following. Balance and predict the following. And you'll get something like HNO3 plus, I need a periodic table to make sure I'm not making up an illegal substance, Mr. Dueck. Really, really quickly. ZnOH2. And I'll do this, but I won't tell you what the product is. By the way, who remembers what the fancy word is for the input here? It begins with the letter R. Do you remember what we call the stuff on the left side? The reactants. I won't tell you what the product is. But, Courtney, half the battle here is I've given you, Sage, reactants that are familiar. What did I call this? Can you read this to me, please, Cam? What? Okay, say again.
Acid, base, neutralization.
What is this? This is an acid. What is this? A base. Anytime there is an acid-base reaction, here are the results. Don't write this bit down. You're going to get a salt plus water. That part you need to memorize, except don't memorize the word salt. It is a salt. I'm going to show you how we put it together. You know part of this. What's the chemical formula for water, Matt? Okay. Now, where did that come from? If you're wondering, that and that. There is an HOH hidden there. The hydrogen that makes the acid an acid, and the OH, Allison, that makes the base, becomes water. And then what's going to happen is, I'll change colors, these two are also going to combine. That's your salt. That's your salt. But I have to crisscross properly. What do I mean by that? Over here, off in the margin, I'm going to say zinc. What's its ion charge? Can someone look that up on their periodic table? Zinc, what's its ion charge? 2 plus? And NO3, which is nitrate or nitrite, or what's NO3? What's its ion charge? Minus? So the salt that's going to form is going to be 1 zinc, 2 NO3s. And I had somebody who was in yesterday as an elf saying, I don't understand the crisscross part. This is the crisscross part that we just did. Well, no, we haven't balanced it yet. This gets you 1 mark out of 2. Now, I have to go back and do the balancing. And I haven't, well, is that big enough to read in the back corner, Jasmine? Is my handwriting still large enough that you I just shrank the screen down. Can you read it okay still? Yeah? Okay. If I need to go bigger, I will. I just can't get the green part on the same screen as the blue part. I'll read out what I'm doing. Now we need to balance. We need to balance What do we save for last when we're balancing? Hydrogens and, in fact, oxygen. Okay? You guys good? Okay, a little focus. So, Alex, I'll pick on you, my friend. How many zincs are there on the left? I think so. How many zincs are there on the right? 1. How many NO3s are there on the left? Now, the most common mistake, kids say, there's 3 of them. There are not 3 NO3s. How many NO3s are there? We're treating it like one funky atom because it's a polyatomic ion. There's 1 of them. How many NO3s on the right-hand side? 2. Ish. By the way, the fact, I'm already thinking maybe I'm going to put a 2 in front of the left-hand side there, but let's keep going. How many H's, hydrogens, are there on the left? Now, you have to be very careful here. How many right here, Alex? 2. How many right here? For a total of? How many H's on the right? 2. How many O's on the left? Now be careful. Look up, look up, look up, look up. Don't count this O. We already counted, Allison, this O is part of the NO3. We kept it together. So, Alex, how many O's are there on the left? 2. Don't count that one. How many O's are there on the right? Don't count, don't count, don't count those ones. Just there. 1. Is that okay? Now we balance. But most of you, if you can get to this stage, you're in pretty good shape. Talk me through it, Alex. Suggestion. Are the zincs balanced? Right now, okay. Let's go, how about the NO3s? So what might we do? Okay, I'm going to put a 2 right here. Now, as soon as I do that, I get 2 NO3s, but what else have I changed? What else is sitting right here, Julia, my joy? An H, so now I got to recount these. Ready, ready, ready? How many H's right here? 2. How many right here? For a total of? Let's fix that. Zincs are balanced? I think so. NO3s are balanced? What did I say we'd do next? Hydrogens. And what we're really hoping is, Tyra, if we're lucky, the oxygens take care of themselves. So hydrogens, keep going, Alex. How many H's on the left? How many on the right? How can I fix that? That gives me 4. What else did that change? Are we balanced? Yep. This is the kind of question you're going to get on your test. This is an acid-base neutralization reaction. Why acid-base? You can see the 2 chemicals. Acid starts with an H, base ends in an OH. This is an acid, this is the base. What you have to memorize is what the product is. Water, and the metal from the base combines with the nonmetal from the acid. And we call that a salt. Oh, by the way, if you wanted to then get the salt on its own, if you boiled this, the water would evaporate. You'd have a powder on the bottom of your beaker. That's your salt. Why is it called neutralization? Because acids and bases are opposite. They would neutralize each other. In fact, if you measured this carefully, if you added the right amount of HNO3, and is HNO3 one of your acids? Yeah, nitric acid. And you added the right amount of zinc hydroxide, after you shook them up and mixed them together, you could probably put your hand in there and not get burned. They would have neutralized each other. Okay? That's an acid-base neutralization reaction. That's one type of reaction you can expect to see. I'm going to give you one that I want you to try on your own. I'll do it up here if you get stuck. So here's another acid-base neutralization reaction. That one's too easy. Let's do a yuckier one. Where am I going here? 3 PO3 combined with, how do I know that's an acid? Starts with a hydrogen. And so in this unit, that's going to be an acid. There are other things that start with hydrogen, but not in grade 10. Plus, I'm trying to do some quick rearranging. BeOH2 gives So you ready? Conlon, how can I tell that this first reactant is an acid? Starts with N. And how can I tell this is a base? Ends with a? And again, don't write this part down, but if I mess this up, this OH and this H will combine to form water. Now I realize there's 2 OHs and 3 hydrogens, so we're going to have to do some balancing later. But one of the products, I guarantee, for an acid-base reaction is always, but leave a space in front of it because I might need to put a number there. What's the other reactant, what's the other product going to be? This metal and that nonmetal, ionically. But I have to crisscross. So, off in the margin, I have beryllium. What's the charge on beryllium? 2 plus? Cam, you see how we found that? I have PO3, which is either phosphite or phosphate. Heck if I can remember. PO3 is phosphite. What's its charge? 3 negative. So first of all, just getting the right formula, the right ratios, it's going to be, I'm going to pick on you, Cam, BE, how many? What's the subscript going to be?
3.
Yep. And PO3, how many of those?
2.
How do I show that it's on everything? Right, I got to put it in brackets. Good, balance that. I'll balance it. Let's see if we get to the same thing. Then I'll show you the other 2 types of reactions that you're going to see. Then the rest of the class, I'm going to give you the crossword and the big take-home quiz. Oh, and I'll take any other questions. By the way, Sage, this is answering the questions you had also that you were wondering, right? It's going to be the same idea, although they also had some words. I don't think I'm going to throw that at you on your test. Anyways, I'm going to balance. Go in the same order, Mr. Dueck, and be consistent. How many H's are there here? 2. How many PO3s are there? 2. How many BEs are there? 3. How many O's are there? 1. Okay. Don't do the H's or the O's. Save those for last. Oh, beryllium. 3 of them. 2, 6. 2 times 3, 6. And 3 already, 9. I think. I hope, I think. Maybe. Yeah? No? Yeah? Right? 2 times 3, 6, and 3 here, 9. Or is that a German student saying, no? Oh, okay. PO3s, I got 1, I got 2, so my next guess, I'd try putting a 2 here. Now that's going to give me 2 of those, but that's changed hydrogens total again. 2 times 3, Allison, I got 6 here, right? And I got 2 times 3, 6 here, so I got a total on the left of 12 hydrogens. Is that okay so far? Have I got my berylliums balanced? 3 and 3. Have I got my PO3s balanced? 2 and 2. What I'm going to move to next? Oh, and I just got a nerdy little smile adrenaline rush because I did it in my head and I saw oxygen does take care of itself, doesn't it? Oh, because I went, okay, 12 hydrogens, 2 here. So I said, I guess I'd put 6 here, which would give me 12. Oh! Magic. So if you had trouble with or you hadn't done from the salts homework from section 5.2, this page here, so the first page was recognizing, but then there was a bunch where you had to, I said, do on a separate page. You can try these ones. What other kind of reaction might I give you on your test? Well, the other thing that we talked about then when we got to the end of the salts is we looked at if you mix a metal oxide an acid and a metal, or a metal oxide in water, or a non-metal oxide in water. I'll be honest, I'm going to ask you acid and metal. That's it. So let's do that one. So this first type was acid-base neutralization. The second is acid plus metal. Like, hey, someone give me an acid from the back of their pink sheet, but don't use Chaku, because that one's weird. What's its formula? HNO3 plus, oh, you know what we did in the lab? What did we drop? What metal did we drop in the lab? Okay, so here's what you need to memorize. When you add a metal to an acid, one of the outcomes is not water, it's hydrogen gas. That was the bubbles. So that's going to come from this. What also is going to happen is the magnesium is going to, metal, is going to combine with this non-metal. It's very similar to the acid-base neutralization, but different stuff is pairing up. So we're going to combine Mg and NO3. Oh, I have to crisscross. I can't just go, hey, MgNO3. It might not work. Might not be stable. So off in the margin somewhere, I'm going to write Mg. That's 2 plus, right? Magnesium? I have no idea what NO3 is. I haven't memorized the polyatomic ions. Negative? Just -1? Okay, so the product is going to be 1 magnesium and 2 NO3s. Now we have the skeleton equation, but it's not balanced yet. Let's balance. You know what? I'm going to do magnesium first because that's what I'm going to start with. I got 1. I got 1. Oh, maybe it is balanced. Shoot. No, it's not. NO3s. I got 1. NO3s. I got 2. H's. I got 1. H's. I got 2. By the way, why did I put H2? Why didn't I just put a single solitary H? Who are we remembering? Mr. Who? Mr. Hofbrinkel. Okay. Hydrogen is always going to be diatomic. And whoever said diatomic, yeah, nice way to pull out that word by itself. Yep. No, here's where you're going to have to, this is the part, Courtney, you have to memorize. If you notice, it's an acid plus a base, and I think I'm going to give you 2 of those. You have to memorize water plus the salt. Because the definition, a salt is what you get from an acid-base neutralization reaction. When you combine an acid and a base, you get water and a salt. This is called a salt. But you have to memorize that the metal from the base combines with the non-metal from the acid. Okay? And then if you look, Acid plus metal, very similar, but because this doesn't have an OH to form water, it's going to be, the hydrogen is just left by itself. I don't get H2O, I just get H2, but the metal combines with the non-metal from the acid. Okay? Let's keep going. I haven't balanced yet, I don't think. Talk me through this, anybody? Let's balance. Sure, Kyle. 2 here? That gives me 2 of those, 2 of, oh, and we're done. So I'm going to make these worth 2 marks. I'll give you 1 mark for predicting the product correctly. In other words, getting this part but not balancing it. And then, Tyra, I'll give you 1 mark for the balancing. And what are the 2 I'm going to give you? I'm telling you again. An acid-base neutralization reaction. Oh, look up, look up, look up, look up. An acid-base neutralization reaction and an acid in a metal. You pick up the little hint there with my body language? Okay. That's the last page of the test. Now, what else is going to be on there? You've got to be able to recognize an acid and a base and an organic and an inorganic and a salt. How do I know it's a salt? It's not an acid or a base or an organic or an inorganic, and it's a metal plus a non-metal. Okay? You are going to need to know, salts notes, you do need to know that if, oh, what's a metal oxide? What's a metal? What's a metal? What part of your periodic table are we talking about? Okay, left side, metal. What would oxide imply? So if you have a metal plus an oxygen, and you combine that with water, that gives you a basic solution. I'm not going to ask you to balance that equation, but you need to know that metal plus water gives basic. Why? Actually, what I'm really fussy on is the next one. A non-metal oxide. What's a non-metal? You guys awake? You guys focused? A little bit more. On the right side, what's an oxide? Oxygen. Carbon dioxide. Carbon monoxide. Silicon dioxide. All of those are non-metal oxides. Here's the problem. When those dissolve in water, you get an acid. This is why when carbon dioxide and carbon monoxide from burning fossil fuels goes in the air, one of the byproducts is acid rain. We talked how out east especially they have a lot of acid rain because they have coal-burning power plants. We don't have very many, if any at all, in BC. We get our power from hydroelectric power, which is pollution-free, but it killed our salmon runs. So you can't win for trying. But anyways, we thought it was a good idea at the time. Okay? So you need to know that. Otherwise, let me pause the video. What can you work on for the rest of class?